Okay, this is the second part of numerical programming exercises set 2. So we're looking at exercises 6 to 10 in this set. We're using Julia 1.6.1, we're using Jupyter Notebooks, and this presentation is aimed at university students, engineering students, science students, math students who are new to programming. Okay, and also I've sort of assumed that you've seen the first half of this video because I'm just going to continue on. So points I've made already, for example, about comprehensions, I've assumed that you've seen that first part already. Okay, so anyway, question 6. Create a 10 by 10 matrix with row values ranging from 0 to 9. Okay, well, previously, this is something very similar to the question 1 on this set, which was setting up a checkerboard. We'll start off by setting up a matrix of zeros. Okay, and again, I'm just going to specify them as integers. And what I'm going to do in this case is add a vector of values from 0 to 9 to each column. Okay, now I'm not sure if it's the row or column. Well, I do know if it's the row or column. It's column wise. Okay, that is sort of what we're looking for. That's a good start. Okay, uh, just adding 0 to 9, which is 10 items, created as a vector. Okay, and just adding that to each column. But it's not exactly what we've been asked to do. We're asked for the rows to have the value 0 to 9. So it's a quick fix. What I'm going to do here is use the linear algebra package using linear algebra, and then just get the transpose of M. I just created this as M. So that's good. That's what we need. That gives us the answer we're looking for. Okay. Usually you put these package calls using linear algebra, using statistics up at the top. I think that's what people normally do, but I just have it here just to be mindful of it, that I needed to call transpose, which is a matrix function. Okay, linear algebra function. Another way of doing this is a comprehensions. So essentially what we have here is an expression. Here it's just y, for and some iterables. Here we got two ranges. X is 1 to 10 and 0 is 1 to 0, 1 to 10, and y is 0 to 9. Now there's 10 items in that. Okay, uh, so the first item will have index 1 but will have value 0. Okay, so just think about that for a second. What we're looking at here in the comprehensions is ranges. So they both have indices. In the case of x, it's 1 to 10, and y is 1 to 10, but they have different values. X will also have 1 to 10 as the values, but y will have 0 to 9 as the values. So just make a distinction in your head between the indices of the ranges and the values in each element of those ranges. Okay, it's a little bit tricky to get your head around it, but that's why I recommend lots of practice with comprehensions as you progress. So the value really is just takes the value y. Okay, that gives us it there. So we have a 10 by 10 matrix, and the value, the expression in each row just takes the value from this range. That's it. Okay. Practice, lots of practice with comprehensions is something I would advise just as you progress. Okay. Anyway, we'll move on. Create a vector of size 1000 with values ranging from 0 to 1, both excluded. Okay, so it doesn't really tell us what exactly we're required to do here, but I recommend, and also it doesn't tell us what values we have, so let's just sort of assume that they have to be evenly spaced. Okay. Also, what I'm going to so it tells us that we have to exclude 0 and 1. So it should start at the first suitable value above 0 and the last suitable value just before 1 on the number line. Okay, and in that case we're going to exclude 0 or 1. So when we exclude 0 or 1, there should be 1000 items, members, items in the vector. Okay. So what we need to do there is create 1002, and we're going to use the linrange command there. So that creates a evenly spaced range between 0 and 1 of 1002 items. And what we're going to do then is exclude the first one and the last one. Okay, so what this means here is we start at the second item and then we finish at the 1001st item. So we're excluding number 1, item number 1, and then item 1002, which is 0 and 1. Okay, so I tell you what, let's just break that up in stages. There's a lot going on here. If you're not familiar with the linrange command, I'll just actually make it a little bit easier. We'll just go for 12. Okay. So 0. This is when we have 12 items there. They're all evenly spaced. And then it finishes at 1. So what I'm going to do there now is just exclude 0 and exclude 1. Okay, so we get a 10 item array. 10 element array. Okay, so that's all we're doing there really. So just actually 1002. Just a bit of guile here, just to remember that we need 2 extra items that we then exclude, and then we just pick out the relevant range of values of the items that we do want to include. That's it really. There we go. 1000 element linear range made up of floats. That's it. Okay. So create a random vector of size 100 and sort it. This one's actually straightforward enough. This creates a random vector and this sorts it permanently. There we go. That's it. If you don't have it sorted, if you don't put in that exclamation mark, if you don't have it permanently sorted, if you were to call it again, it will just go back to the way it was created by this command. But let's just sort it permanently. Okay. Now, consider 2 random matrices A and B and check if they are equal. So that should be A and B. Okay, copy and paste error. This is another straightforward enough one. So this takes the values, any value between 0 and 2, and it has a 2 by 2. Let's just check that out, just see what that looks like. Okay, it's integers, and yeah, that's it really. So just check if they're equal. So B will be something similar to that, and we'll just check if they're equal. Most cases it's going to be false. So anyway, point of that one is just to see if 2 matrices have the same values. It'll be a bit far-fetched if they're randomly generated, but it's not impossible. Okay, so and create a random vector of size 1000 and find its mean value. Now this one's straightforward enough as well. So the last 2 are fairly simple. So here we have to call the statistics package using statistics. If you're finding mean, standard deviation, range, median, all those ones, you just have to call using statistics, and that will allow you to use all of those functions there, mean, variance, and so on. So just create Z there and find its mean. There we go. So as expected, it's very close to 0.5 because it's generating a set of random numbers between 0 and 1. Okay. Right, that's it. That's a set 2, part B done. I think actually The first half of this was a bit hard in the second half, but you just keep getting better at it and progressing at it. Okay, leave it there.